In this video, I am going to discuss transformations of functions. So let's see how transformations are done using formula method. So in this graph, the first graph, where you have the basic function, which is y equals square root of x. So when x is 1, square root of 1 is 1. So likewise, this is a basic function, which is square root function. Now, I have drawn this one, which is y equals 3 of square root of x. It means this 1 is moved to 3, but this x coordinate is not changing. It is constant. It is the same. This y coordinate is changed from 1 to 3. Why? Because 1 times by this factor here. So this is like a spring. You have a spring here. The spring is stretched by 3 times. It means 1 times 3. So vertically stretched. That's why I drew a vertical line. You can draw this vertical line anywhere on the graph to see how the stretch factor works. So your x coordinate doesn't change. So y coordinate, which is 1, becomes 3 here, because you multiply by 3, you stretch this point, this spring, 3 times here. Now let's come to this graph, where you have still the basic function, and you have vertically stretched this point 3 units, right? We discussed. Now here 1 is added separately. So 3 plus 1 is 4. So this is 1, 4. So you can see here, this is 1, 4. So 1 times 3 is this 3. 3 times you stretch vertically, then just move without stretching or compression, 1 unit up. So this plus 1 means upward, movement upward. So 3 plus 1, 4. So new point is 4. So that equation now is 3 of square root of x plus 1. That is, still you have vertical line here. Whatever vertical line, maybe here, then only you can check the stretch and movement upward. To check in this graph, we can check horizontal stretch or compression, where you have horizontal line. It means your y coordinate doesn't change. So now I choose this point 9, 3, where y coordinate is 9. Sorry, y coordinate is 3, x coordinate is 9. So what happened to this point? It came to 4.5. But your 3 is still doesn't change. It is not changing. So it means you are checking your horizontal stretch or compression, keeping your y coordinate constant. So 9 divided by 2 is 4.5, because this 9, because this 9 is divided by this 2. Here, multiplication, when 3 is outside the square root, when coefficient is inside with x, the square root, then you divide. 9 divided by 2 is 4.5. Then when you come to this graph, still y equals square root of 2x, 4.5. Then minus 3. It means along horizontal. This means along horizontal movement is 3 units. What happened? 4.5 plus this 3 is 7.5. It means this was compressed to this, like if you have spring here, The spring is compressed to this, then compression is stopped. Then you just move 3 units to the right. Why? Your this in the standard formula, this is negative. It means D is positive. D means movement to the left or right, but since this D is positive, positive means to the right, then 4.5 plus 3 is 7.5. So this is the final transform point for this graph, for this graph. Now let's go to this graph where we incorporate both horizontal, vertical and horizontal compression, horizontal movement, vertical movement, and horizontal movement, everything together here. Now still this is your basic function. So we originally selected this point for 2. But here we chose 1, 1. Here, here also 1, 1. But here 4, 2. Never mind. You can choose 1, 1 also here. But I chose here 4, 2 for you to understand clearly. Square root of 4 is 2. So this is basic function. Point is 4, 2. That point is transformed to 5, 7 using all these transformation factors. How many factors? 4. 1, 2, 3, 4. This is vertical stretch by factor of 3, horizontal compression by factor of 2, movement to the right 3 units, movement upwards 1 unit. Here 1 unit, here 3 units. That is this and this and this. So let's see how you get that. This is not necessary. So y transform general formula is A times YB plus C. X transformed means XB over K plus D. These two are the formulas, general formulas. So this is the final equation, this one. So A means here 3. A means 3. So 3 times Y basic. Y basic is here 4. So 4 times, sorry, Y basic is 2 here. 2 times 3 is 6. 6 plus 1 is 7. So that's why you get 7 here. Then X transformed is X basic is 4. X basic is 4 divided by K, which is horizontal compression. That's why you divide. Compression means you reduction. So you divide and move 3 units to the right. You add 3, then 4 divided by 2 is 2 plus 3, 5. So your new point is 5, x coordinate 5, y coordinate 7. So that is this. So it is like this. Here 2 times 3. 2 is multiplied 3 times, stretching up to 6.6. Then you move to 0.1, move by upward by 0.1, 1 unit, then 7. So it is here. Then basic x is 4 divided by 2. 2. It means it moves to this point. Then again, from here, you move 3 units to the right. From here, 1, 2, 3, here. Then 5. So 5 and 7. This is the new point. So this is the transformed point. So this is the standard formula where this is A, this is K, this is B, this is C. So then let's move to the next slide, which explains you how to graph using t-chart. It means we are discussing only one point here, how to transform one point to this. But you have so many other points on the graph like this. This is basic graph, y equals square root of x. So when x basic is 0, 0, 0 here, 4, 2, which is our selected point, 9, 3. So likewise, it goes this way. So you can have a couple of points in the basic function, and we can discuss here transform t-chart. This is the point, this is t-chart. So how x transform means x basic divided by k plus d. So here k is 2. So x basic is 0. 0 divided by 2 plus d is this 3 units to the right because you have negative. So 0 divided by 3. So this point is transformed to 3. Sorry, this coordinate is x coordinate, x basic is transformed to 3, x3. Then y basic. Y basic, what is the formula? A times yb plus c. A means this. Here 3. 3 times y basic is 0. 3 times 0 plus c. C is this. 1 unit up because you have positive here. Otherwise negative. So 3 times 2, 6. 6 plus 1, 7. So this is 5, 7. This is our selected point here, which is transformed to this. So 4.42 is transformed to 5, 7. Likewise, you can do all other points. So basic 9 is transformed to 7.5. Basic y coordinate 3 is transformed to 10. So this point 9, 3, it will be transformed to 7.510. Likewise, this is transformed to this. This is transformed to this. Then these are the new transformed points of these basic points. So you can plot these points, then you will get you can get this graph. Then sometimes you can have a reflection on x-axis like this, where your 3 is this, a is negative. So a is this. When this is negative, so negative 3 here, negative 3 times 2, negative 6 plus 1, negative 5. So this point will be negative 5. It means down here. It means reflection on x-axis. Likewise, you can have your k negative, this 2 negative. So if this is negative, say this is negative, this 2 is negative, 9 divided by 2 is negative 4.5 plus 3, negative 1.5. It means your x coordinate goes to negative side here. It means this, not like this, it will be like this, reflection on y-axis. K is for reflection on y-axis. When k negative, reflection on y-axis. When a negative, reflection on x-axis. But when you use this formula method, you don't want to worry about reflection and all these things because the points automatically gives you reflected points. So I think this is all about transformations. So I hope you understood the concept here. Thank you for watching.